This lecture is part of an online course of Calculus 1, and I'm going to talk about polynomials, which is one of the essential classes of functions. As I said in the previous video, they are very helpful in mathematical models. Okay? So, a polynomial looks like this. F of x is equal to a0 plus a1x plus a2x to the power of 2, a3x to the power of 3, up to anx to the power of n. So what are the indices? What are these numbers? So n, or basically all the exponents, are some positive integers. When n is a non-negative integer. So as you see, we don't have any fraction, we don't have any negative exponent on the exponent position here. Then let's talk about a0, a1, a2 up to an. What are they? They're called coefficients. Coefficients, which are basically some constant real numbers, which are constant real numbers. Okay? Then we say that if an is not 0, then we say that the function f has degree n. Let me move this line a little bit. There you go. Okay, let's look at an example. For example, a polynomial looks like this. 2 minus 4x minus 5x squared plus 8x to the power of 10. 8x to the power of 10. Okay, so as you see, 2, -4, -5, and 8, they are coefficients. They can be some also. Let me put some real numbers like this, 8 root 2. So all of them are called coefficients. What about the degree? As you see, this is 2x to the power of 0, -4x to the power of 1, -5x to the power of 2, and 8 root 2 x to the power of 10. So the degree of this polynomial is equal to 10. It's just because this is the largest exponent that we have in our polynomial. That's called the degree. Okay, the largest exponent. So here it says that if the coefficient is not 0, okay, we say that the degree of our polynomial is the largest exponent that we see here. Let me give you two notes. So note 1 is that if the degree of our polynomial is less than 1, less than or equal to 1, then f is a linear function. How is that? Well, just think about this a little bit. So in that case, y would be f of x, which is equal to a0 plus a1x to the power of 1. This is a straight line that we discussed in the previous video. Straight line. For example, if f of x is equal to 5, degree of this polynomial is 0. It's just a line. You see, what line is that? It's just a constant line. If this is x-axis, this is y-axis, then y equals to 5 is this line. Okay, and if, for example, f of x is equal to, for example, 2 plus, for example, -10 x. Then the degree of this function is 1, and it's a straight line. We discussed it before. So we can say, based on this note, that linear functions are special type of polynomials. And the second note that I want to discuss about domain and range of that. So the domain of the polynomial, what do you think? So the domain is basically the set of all the inputs, the set of all the numbers that you can put for variables into the function. So this is our polynomial. As I see, I don't have any fraction for the variables. I don't have negative exponents. Everything is very nice. So I can put all real numbers for my variable x in here. So I can say that the domain is all real numbers. How about the range? Range is basically depends on the degree of the polynomial. I'm gonna discuss it a little bit later. Range depends on degree of the polynomial. Okay.